Good morning, our listeners, and welcome to our today's class. Today, we will be continuing to look at the concepts, measures of central tendency, and dispersion. We already had started looking at these concepts in our previous class. When, on the course of trying to look at it, we began by looking at data itself. We equally looked at a method of data collection, sources of data, looked at what we call sampling and sampling techniques, which of course gave us a background about the measures of a central tendency and dispersion. Because when you talk about calculating measure of central tendency and dispersion, which of course concern descriptive statistics, you talk about the data from where you are going to calculate these values from. So in that previous class, of course, we said that in our next class, we are going to continue to look at the measures of central tendency as it concerns an array of data, measure of central tendency and dispersion as it concerns ungrouped frequency table, and measures of central tendency and dispersion as it concerns grouped frequency table. Reason being that we said in the class that having a data in our hand or having data in our hand, that we can present this data we have in hand either in a form of what, an array, or we can present it in form of what, table. And then under this form of table, we can either present it in ungrouped frequency table or we can present it in grouped frequency table. Therefore, on the course of calculating the measures of central tendency, we are going to calculate it in form of what? From an array of a data, calculate it from ungrouped frequency table, and calculate it from a grouped frequency table. Other method of course, data presentation, we'll be talking about charts and graphs, which of course we are going to address when we are through looking at measures of central tendency and dispersion under these headings. So today, we are going to begin by looking at measures of central tendency and dispersion for an array of data. So permit me to clean the board and then retain this first one. But then I encourage you that situation whereby you have not looked at in our previous notes or looked at the video of our previous class, that you are encouraged to have more background information about what we are doing today. You can consult it. I think it is going to be tagged either Introduction to Measures of Central Tendency and Dispersion. So permit me to clean this. I said today we are going to look at measures of central tendency. Measures of central tendency and dispersion for an array of data. Array of data. Okay? So, of course, we are beginning with a central tendency. The measures of central tendency that we are going to consider in our today's class are under this measure of central tendency. Central tendency. We are going to look at what? The mean. We are going to look at the what? The median. And we are going to look at the what? The mode. Then under the measure of dispersion, we are going to look at the what? The range. We are going to look at the what? The variance. We are going to look at the standard deviation. Standard what? Deviation. standard deviation. We are equally going to look at what we call coefficient of variation. Coefficients of variation. And possibly look at what we call skewness. Look at what we call what? Skewness. Look at what we call skewness. So, mean, median, mode under central tendency for an array of data. Then talk about the dispersion range, variance, standard deviation, and then coefficient of variation, and possibly the skewness. So you permit me to clean the board while we begin with the what? With the mean. We begin with the mean. So I'll clean. So we start with the what? With the mean. Yes. When we talk about the mean of a set of data, precisely the arithmetic mean, what we are discussing here is arithmetic mean. We are talking about the sum of all the observations all over the number of what? Observations. For instance, if our data sets are represented, the array of the data set is represented as, we have what? X1, X2, Xn, up to what? X what? 3, up to what? Xn. So there are n observations that we have. So if we want to find the mean of these n observations, we are equally going to have something like this. Of course, this mean is represented with what? X bar. That is the mean of a sample. So which means this X bar, which is talking about mean, is given as X1 plus X what 2 plus X what 3 plus what X what n, all over. There are n observations that began from 1, 2, 3 down to what? To n. So you are going to have all over what? N. Of course, this thing can be written as a X bar equals summation. I begins from what? 1. I begins from what? 1. This is 1, this is 2, this is 3, and ends at what? At n. So I have what? N. Of what? X, I. All over what? N. All over n. So this is actually the formula for what? For mean. Summation of xi all over what? N. For an array of a data. That is, data set that does not contain frequencies. This is the formula for what? For the mean. Okay? So this, when we now talk about the mean, the next we are going to talk is what we call the median. What we call the what? The median. Of course, when we talk about median, we are talking about the central observation when the data set must have been arranged either in ascending or descending orders of their values. That is what we call the mean. Sorry, the median. The central observation when the data set must have been what? Sorted, either in ascending or descending order of their values. That's what we call the what? The median. So when we talk about the what? The mode, we are talking about the value or the data or the observation that has the highest number of what? Occurrence, or has the highest frequency. That is what we call the what? The mode. A data set or a value or an observation in that data set that has the highest occurrence. That is what we call the mode. There is a relationship between the mean, the median, and then the mode. And this relationship between the mean, the median, and the mode is represented this way. That the mean minus mode equals to 3 into mean minus what? Median. This is a strong relationship that exists between these three measures of central tendency. That the mean minus mode equals 3 into mean minus median. Therefore, somebody can be given the mean and the mode and asked to find the what? The median. The moment you know this formula, you are there. You can equally be given the mean and the median and you are asked to find the what? The mode. And the moment you know this formula, you are there. So these are what we are going to say for now about the mean, the median, and the mode of an array of data. An array of what? Data. We are equally going to look at the measures of dispersion for an array of what? Data. So that when we draw one example, we'll be able to look at the measures of central tendency and dispersion concurrently. So permit me to clean this illustration we gave about measures of central tendency and be able to give the illustration about measures of dispersion while we take real example or while we take an example. So permit me to clean this. We did mention earlier that we are going to look at under measures of dispersion, that we are going to look at what we call the range. We are equally going to look at what we call the variance. We are equally going to look at what? STD. Let me say that this STD stands for my standard deviation. Then we are equally going to look at what we call the coefficient of variation. Coefficient of variation. Coefficient of variation. And then we are going to look at possibly what we call skewness. First of all, we begin from range. Of course, range is defined as the maximum observation minus the minimum observation. So range equals max of what? X minus mean of what? X. That is maximum value of what? X minus the minimum value of what? Of X. Or you can say where they say highest minus lowest. Where this highest stands for highest value of X, lowest value of what? Of X. This is what we call the range. Then when we talk about the variance, variance of course is given as variance, which oftentimes or most of the time is represented with what? S squared. That's variance. Is given as summation of what? X minus what? X bar all over what? N. This is all over N when there is a condition. That condition is N is greater than or equal to 30. That is N is a large sample. So we have that a condition here, N is greater than or equal to 30, making N to be a larger sample. But then when this N is not up to 30, we are going to use another formula. And the formula we are going to use stands that variance is going to be given as summation, open a bracket, X minus what? X bar, close the bracket, all over what? N minus 1. This condition is when N is strictly less than what? 30. So we use this formula when our N is greater than 30, but we use greater than or equal to 30, but we use this formula when N is less than 30. This one is all over what? N. This one is all over N minus 1. This is the condition about variance. And we are still talking about variance of an array of data. because we are not discussing data with frequency. That's why you cannot see anything about frequency here. You cannot see anything about frequency here. Now, oftentimes they say that this thing which I have on the board is not a computational formula. Because if you are given a data set, you end up now going to calculate the mean first. And coming back, subtracting the mean from each of the observation. In fact, this is squared. Sorry, this is what? Squared. And then you come back and calculate what? The mean. Subtract from each of the observation. Square it, sum it, and divide it. So it takes a longer time. So oftentimes they say these are not a computational formula. How do we get out computational formula from this formula? Watch what I'm going to do. So permit me to clean this top. We talked about the range, max minus mean, highest minus what? Lowest. We talked about variance. This formula when n is greater than or equal to 30. Talked about variance. This formula when n is less than what? 30. Let us see how we can get the computational formula from this formula, which we are going to use when we take example. So permit me to clean. Of course, we are told that this variance here, which is represented by this, that this variance s squared, which I have, which of course is given as what? Summation, that I, or let me just say summation x minus x bar all squared all over what? N, can be given as that this equals summation of what? X all squared minus n of x bar all over what? N. That this formula and this formula are the same thing, and it is true. This and this are the same thing. Now we go ahead. So I want to express this one further. This one becomes summation. Here is my x squared minus. The value here is what? Is n. And of course we know that this x bar that is here is the mean. And mean means summation of what? X all over n. So in place of this n, permit me that this x bar is squared. This is minus n x bar squared. So if I come in the place of this what? X bar, I am going to write the formula for what? For the mean. And of course you know that formula for mean x bar is given as what? Summation of x all over what? N. This is the formula for the mean of an array of data. So if I come in place of x bar, I am going to put this. So this n is this n I have here. In place of this x bar, I'm going to write summation of what? X all over what? N, which is what I have here in place of what? X bar. But this x bar here is squared, so I'm going to do like this, all what? Squared. I will say all over. This n is here. I will say all over n. Permit me to clean this one. So now what I have here now becomes, so this equals summation of x squared for this minus, here is my what? N. Then remember that I'm squaring this. Squaring the numerator and squaring the denominator. So if I square the numerator here, what I'm going to have is summation of x all squared all over. If I square the denominator, which is n, I have n what? Squared all over the n I have down here. There is n here, there is n square here. So this n will reduce, cancel off this square. And then what I have now finally becomes that this equals summation of x squared for this, then minus. We have summation, what I have here is what? Is x, all raised to power what? 2, all over. N is remaining here, then all over general n. So this thing is what we are going to use, and we call this one computational formula. Reason being that in this one, we just need to square all the observations. We need to sum all the observations and square it. Divide it by n, divide the general thing by n. And by so doing, we have calculated the variance. Instead of going through calculating the mean, x bar, and going to subtract it from each of these observations. So I want you to bear this formula in mind for me, that this formula is the formula of variance. The same thing applies here. The only difference between this and this is that while the denominator here is what? Is n, the denominator of this one is going to be what? N minus what? 1. Here, after solving this, I have here to be what? N. I have here to be N. Simply because here was what? N. But here is what? N minus 1. So this formula and this formula, of course, when N is less than 30, is going to be the same thing here. Only that, why the denominator here is what? Is N. The denominator here is going to be N minus 1. Because the only difference between this and this equal is that why this is N, this is N minus 1. This is what we call computational formula for the variance of an array of data. So I want to believe that we are not confusing you. When we take example, we make everything very clear. So let me go to the next thing. Then when we talk about standard deviation, talk about what? Standard deviation. Of course, standard deviation we know is the square root of variance. So if I say standard deviation S is square root of what? S squared, which is square root of summation x raised to power 2 minus summation of x all raised to power 2 all over n all over n. That is a condition n greater than or equal to 30. Then or we have that s equals what? Square root of s raised to power 2 equals square root of summation of x all squared minus summation of x all squared all over what? N all over n minus 1. So this is now what we call the standard deviation, the square root of variance. Square root of what? Variance. Okay? So permit me to equally now clean it and talk about another measure of dispersion, which we call coefficient of variation. Coefficient of variation. Coefficient of variation. Coefficient of variation. At times they write this in C dot V. C here for coefficient, V here for variation, is expressed in percentage. That is 100 multiplied by S all over what? X bar. Where this S is standard deviation. Where S equals to STD, standard deviation. And of course, you know X bar equals what? Mean. So the moment you obtain the standard deviation and the mean, you can quickly compute your coefficient of variation. That is what we mean by coefficient of variation. You understand? Okay. Now, permit me to equal the cleaning because we are still going to call up this formula when we want to solve. So the next one we are to talk is what we call the skewness. Skewness is actually the measure of departure of a data set from the symmetry. Yes, from the symmetry. And we can say that a set of data is symmetrical. Or we can say that the curve or the frequency curve of a data set is symmetric when the mean, the median, and the mode are equal. We now say it is symmetrical, that the frequency polygon of that particular data set is symmetrical. And in that case, you are going to have something like this, something that goes this way. So you are going to have a center here, and this center here is going to be where mean equals median equals what? Mode. So when in the center of this observation, mean equals median equals mode now, you now say it is symmetrical. But it ceases from being symmetrical when you have something like this. For instance, you have something like this, Then you have something that goes this way. You see, this one is skewed to the what? To the right. This is skewed to the right. So, and we are told that when the frequency curve of a data set is skewed to the what? To the right, there is a kind of relationship that exists between the measures of central tendency. They say that here, that mode is less than what? Median. which is less than what? Mean. That's what they say here. That of course, when it is skewed to the what? To the right, it has a tail at the right. That the mode here is the smallest, followed by the median, and then the mean. So here mean is highest. So anytime you calculate the mode, calculate the median, and calculate the mean, and you find out that your mean is greater than your median and your mode, know you that the data you are dealing with is skewed to the what? To the right. That is the implication. It is no longer symmetrical. Because when it is symmetrical, you can divide it into two equal halves. What you have at the left and what you have at the right are equal. But when it is skewed, either to the right or to the left now, if you divide into two, they cannot be what? Equal. So this is what I want us to take to mind in this particular thing. Once your mean is greater than these two, your data is skewed to the what? To the right. But then when you have something like this, and you have something like this, you have something like this, this very one is skewed to the what? To the left. Because you can come and have a center here. This one is longer. You can come and have a center here. This one, of course, is longer. It's quite longer. So, of course, we are equally told that if it happens this way, it means that our mean is less than our median, which is less than what? Our mode. That's what we are told. So when you compute and then your mean becomes smallest, followed by what? By the median. Then why the mode becomes what? The highest. The implication is that your data is skewed, the distribution is skewed to the what? To the left. You understand? So when we should be talking about our coefficient of skewness, we will be discussing this. This is what we can say about skewness. So we give ourselves now what we call the coefficient of skewness. Coefficient of skewness. This coefficient of skewness in this our discussion is going to be represented with a letter what? K. And it is given as coefficient of what? Skewness. It is given as mean minus mode all over STD, where STD stands for what? For standard deviation. Or you can equally use that K equals 3, open a bracket, mean minus median all over STD. On the ground that earlier, do remember that earlier we said that mean minus mode equals 3 into what? Mean minus median. So if this is true, it means that mean minus median is the same thing as mean into 3 into mean minus median. So what I have at the numerator here and what I have at the numerator here are the same. And of course, denominator and denominator are the same. So when we want to compute the coefficient of what? Of skewness, we can use any of this formula. Therefore, anybody can give you the mean, give you the what? The mode, and ask you, give you the mean, give you the mode, and ask you to obtain the what? The coefficient of skewness. Or the person can come and give you the mean and give you the median and ask you to obtain the coefficient of skewness. This formula is what we are going to use. Thank you very much. Let us take one example. We are going to take a smaller data set so that it will be much easier for us to handle. And let me say that data set which I'm going to take is talking about, I have what? 0, I have what? 2, I have what? I have what? 1, I have what? 4, and I have what? 6. 1, 2, 3, 4, 5. Let me say this is what I have. And from this, we are going to calculate the following. From this, we are going to calculate the following. We calculate the mean, we calculate the median, We calculate the what? The mode. We calculate the what? We calculate the range. We calculate the what? The variance. We calculate the STD, standard deviation. We calculate the coefficient of variation, C dot V. We calculate our K, which is the coefficient of skewness. We are going to obtain all of these from this data set. To make this thing appear much easier for us, especially when we are going to calculate the median, let us arrange this data in ascending order of their values. That is starting from the smallest and ending at the biggest. If I start from the smallest here now, what I'm going to have here is what? This thing becomes what? 0. The next smaller one is 1, followed by what? 2, followed by what? 4, and followed by 6. This thing has been arranged in ascending order of their values. So I will now come to find the mean. Of course, you know that mean x bar is given as summation of x. I running from 1 to n, then all over what? N. Or in order to make this formula appear simpler, let us be using summation of x over n. So and this thing becomes, to sum n, it becomes what? 0 plus 1 plus what? 2 plus 4 plus 6 all over. How many of them? 1, 2, 3, 4, 5 all over what? 5. 0 plus 1 is 1, plus 2, 3, plus 4, this is 3 plus 4, 7, plus 6, 13. So this thing becomes what? 13 all over what? 5. So the moment you divide this, you'll be able now to arrive, which of course might give you something like, let me say, 6 point something. When you divide this, you'll be able to have 6 point something. This actually is what we call our mean. Okay? So it is not more difficult to calculate your mean and the rest of them in an array of data. Just sum them, divide by what? By n. Sum all the observation, divide by the number of the observation. You have arrived at the what? At the answer. So in the context of the observation we have here, the mean is 13 over 5. Because this is 1 plus 0 plus 1, 1, plus 2, 3, plus 4, 7, plus 6, 13. So it becomes 13 over 5. 1, 2, 3, 4, 5. Thank you very much. It is simple. Then we come for median. They told us that the median is the central observation when we arrange the data either in ascending or descending order of their values. And then the data is like this. We have what? 0, we have 1, we have 2, we have 4, we have 6. Of course, when we say 1, 2, we say 1, 2, then here and here. The central observation is these two. When we have sorted this data in ascending order of their values. So in this case, my median equals what? 2. Okay? The central observations. Okay? Then when we ask ourselves to find the mode, in this case, I think I need to do something for us to be able to come out of this problem. But maybe in the next one, I am going to talk about mode, because if you come here, there is no number that appeared the most. This appeared only one time. This appeared only one time. So in this case, my mode, of course, they can ask you that. My mode is 0. My mode is what? 0. In fact, I am interested in it. So in this case now, my mode is equals what? 0. And when we talk about 0, in fact, it is better not to say mode is equals to 0. We say the mode does not exist. Because if you say mode equal to 0, you might be referring to this 0 that is here. So it is better to say mode in this thing, in this data set, does not exist. Mode does not exist. Or there is no mode. So if they give this kind of data and they begin to say mode equals 2, mode equals to 1, mode equals to 4, mode equals to 6, the last option says none of the above. The answer is none of the above because there is no mode there. So that is about mode in that particular problem. So we now move over to the range. Move over to what? To the range. Permit me to clean this one. Do remember that our mean is 13 over 5. Our mean is x bar equals 13 over 5. And then our median equals 2. Our median equals what? 2. So we now come over to the range. Of course, we are going to come over to the range. And of course, our range R is max of x minus what? Meaning of what? X. Maximum of x is what? 6 minus. Minimum of x is what? 0. So this equals what? 6. My range is equal to 6. Because 6 minus 0 is what? Is 6. Then we now come to variance. So when we come to variance, we are going to use that our formula. We say, so permit me to clean here. Let us be reporting again that my R range, R equals what? 6. So permit me to clean here. So we are going to use that our formula, and that our formula says that my variance S squared is given as what? Summation of x all squared minus summation of x all raised to power what? 2 all over what? N all over what? N. This time around, if you watch, my observation is 1, 2, 3, 4, 5. And this thing is less than 30. So we are going to use N minus what? 1. That is the essence of that condition we gave. That what? N is less than what? 30. And of course, our N is what? Is 5. So we are now going to come, and when we come, what we are going to do is to come here and write our like x, and then write what? X all squared. Our x is what? 0, 1, 2, 3, 0, 1, 2, 4, and then 6. Then under this square here, we pick this with square. So 0 squared 0, 1 squared 1, 2 squared 4, 4 squared 16, and then 6 squared 30 what? 6. This formula says we should sum it. So we now come here and say all over. We sum this. This, of course, we sum before gave us 13. That is 0 plus 1, 1, plus 2, 3, plus 4, 7, plus this is what? Is 13. We sum this one. Summing this one is 0 plus 1, 1, plus 4, 5, plus 16, we have 21. So we have 21 plus 36. We bring down what? 7. This to this is what? 5. So we have 57. Then we now report what? 57 here. So what we are going to do now is to come here. Anywhere we see summation of x squared, we put 57. Anywhere we see summation of x alone, we put 13. So this is going to be x squared equals. In place of this, I am going to put 5, 7 minus. In place of this very value that is here, I am going to put what? 13. So I'm putting 13 there. So what I have there is what? Is 13. And of course, this 13 is what? Is squared. So I'm going to say all raised to power what? 2. All over. My n here means number of observations, and there are 5. So I have all over 5, then all over. Here is my n minus 1. So I have what? 5 minus 1. So this becomes what? 5, 7 minus. Of course, this 13 here raised to power 2 will give me, I think, 169. 13 raised to power 2 is 1, which is just like 13 times 13, which is 13 times what? 13. 3 by this is what? 9. 3 by this is what? 3. 1 by this is what? Is this is 3 by 3, 9. 3 by 1 is what? 3. So I will now come here. 1 by what? 3 is what? 3. Then 1 by 1 is 1. So I have here. Bring down 1. This 3 plus 3 is 6. Bring that. So 169. So I now come over here and write 169 all over what? 5. All over what? 4. Of course, when you divide this 169 by 5, subtract it from what? 57. Divide it by 4. You arrive at your what? At your variance. You arrive at your what? Variance. So this is actually very simple. Just divide this by this. I don't have my calculator in my hand for me to be pressing, and then the decimal point now be coming and the rest of them. So, but the moment you say 169 divided by 5, you have a value. 57 minus that value, or divide by what? 4, will be able to give you the variance. And of course, my standard deviation now is going to be square root of this thing, because my standard deviation S is square root of what? Variance, S squared, which is now square root of 57 minus 169 all over what? 5 all over 4. That is what we have for that one. Okay? So we are going, in this data set, we are going to skip the idea of calculating what we call the coefficient of variation, because mode didn't exist in this particular problem we solved. Mode didn't exist down there. So it is as good as we try and skip that very one. The only thing we are going to compute is now what we call the coefficient of our variations, but we are going to leave the skewness. So permit me to clean these ones. Permit me to clean here. Permit me to clean here. The coefficient of our variation we told ourselves is C dot V, which is expressed as 100 times S all over X what bar. We had our X bar to be this, we had our variance to be this. Sorry, our standard deviation to be this. So whatever thing we get here, we put it in place of this X. And then, of course, this X bar should be put in place of this X bar. Then once we evaluate it, that becomes our answer of this coefficient of variation. Okay? So thank you for still following us and the rest of them. Let us quickly draw another example, very fast. Draw another example so that we know whether we are going to include the one that have to do with mean and the rest of them there. So permit me to clean this place. Okay. We draw a very small example very fast. This is going to be example 2. And that example 2 is going to be something like minus 1, 1, 0, and then 1, and then 2. 1, 2, 3, 4, 5. Let us see whether we can deal with this one quickly equally to see what we are going to get. So we are equally going to do, of course, this one has been assorted, it has not been assorted in ascending order. So to arrange them in ascending order, we have minus 1, we have 0, we have 1, we have 1, and we have 2. So we quickly go and obtain our what? Our mean. So our mean X bar is given as, so we come here. This is summation of X all over N, which equals minus 1 plus 0 is minus 1. So I have minus 1 plus 0 plus 1 plus 1 plus what? 2 all over 1, 2, 3, 4, 5 all over what? 5. This is minus 1 plus 0 is minus 1 plus 1 returns to what? To 0. So I have, this is 1 plus, it becomes 1 plus 2, which is 3. So I have 3 over 5. So my mean is 3 over 5. Because if you come, you can equally say this is 2 plus 1, 3, plus 1, 4. This one is minus 1, which will reduce that 4 to what? To 3. That's why I have 3 over what? Over 5. So this is the mean. So if you talk about what the median is the central observation when you have arranged in ascending orders. So if you come 1, 2, comma, 1, 2, comma, this, which means I have minus 1, 0, 1, 1, and 2. Then 1, 2, you comma it off. 1, 2, you comma it off. The center one is what? 1. So my median is equals what? 1. So the moment you are done with that, we now talk about what we call the mode. Mode we say is the number with the highest occurrence. And if you come here, 1 occurred 2 times. And no other number occurred more than once. Apart from this one that occurred. Which means in this case, my mode equals what? 1 as well. My mode equals what? 1. Okay? So in that case, we move further again. I've got my mode. So we now talk about the range. So the range is highest minus lowest. What is my highest here? Highest is 2. What is my lowest here? Minus 1. So in place of highest, I'm going to write 2. Minus is for this formula. The lowest is minus 1, so I have minus 1. So, and in mathematics, minus is plus. So I have 2 plus 1, which equals what? 3. So let me be labeling what we are obtaining by the side. So we have gotten our x bar to be 3 over 5. We have gotten our median to be what? Minus 1. Median to be 1, sorry. We have gotten our median to be 1. We have gotten our mode to be 1. We have gotten our range to be 3. Our range to be 3. So I'll clean this place for us to go ahead. So permit me to clean here. Having got these values, we now move ahead now to, wow, I've cleaned even the observation, which was minus 1, 0, 1, 1, and 2. These are observations. So I'll now go ahead now to calculate the variance. And calculating the variance, of course, we are going to use that formula which we knew. So I'll first of all come and do x what? Squared. Do something like this. I have minus 1, I have 0, I have 1, I have 1 again, and I have what? 2. Then here is x squared, so I'll be squaring this. Minus 1 squared is 1. 0 squared, 0. 1 squared, 1. 1 squared, 1. 2 squared, 4. I will underline. I will sum everything here. Minus 1 plus 1 is gone. 1 plus 2 is what? 3. So here is 3. Then I'll come. 1 plus 0, 1. Plus 1, 2. Plus 1, 3. Plus 4, 7. And I know that the formula for my words, variance, x squared, is given as that this is summation of x squared minus summation of x, all raised to power 2, all over n, all over what? N minus 1. Because the number of observations is not up to 30. So you are going to use n minus what? 1. This equals. By the implication of this, anywhere I see summation of x squared, I'll put 7. So in place of this, I'll write what? 7 minus. Summation of x here is this 3. So I have to put 3. But that 3 is raised to power 2. So I have raised to power what? 2. All over. Here is my what? N. And that my n is what? Is 5. 1, 2, 3, 4, 5. So I have 5 all over. Here is my n minus 1. So, and that is 5 minus 1, which becomes what? 4. And then this thing becomes what? Here is my 7 minus. 9 squared is what? 3 squared is what? Is 9 all over what? 5. Then all over 4. So the moment you say this 9 divided by what? 5. Subtract it from 7. Okay? Then divide it by 4. You have gotten your what? Your variance. Then you now equally come, my s alone, which is standard deviation, is square root of what? S squared, which is now square root of 7 minus 9 over 5 all over 4. This thing now will give you the standard deviation. 7 here minus 9 over 5 all over 4. Okay? So this is this. Then when you talk about the coefficient of variation, coefficient of variation still remains what we said, C dot V equals 100 times S all over X bar. Your S is whatever value you are going to get here. You put it in place of X. And then your x bar is what we got earlier, 3/5. So 3/5 goes in here, while this goes in here. And that becomes the answer. Okay? So then we now talk about what we call the quotient of skewness. So permit me to clean here while we talk about quotient of skewness. Quotient of skewness. This the formula for variance. The choice of n minus 1 was made use of because the number of observations is up to 30, then down the line. So permit me to clean here. This is 2, of course. So I have this. When we talk about quotient of skewness, we said it is k equals mean minus mode equals or all over STD, which is talking about standard deviation. Okay? Now, our mean is what? Is 3/5. So this becomes what? 3/5 minus. Our mode is what? 1 minus 1 all over. Our standard deviation is everything we are going to get here. Our standard deviation, everything we are going to get here. So I now say my STD, which is the standard deviation. But one thing is important here, and that which is important here is what I want to point out. If you find out here now, if you say 3 divided by 5 minus 1, it will make the numerator to be negative. And our standard deviation is a positive what? Value. So if you say that negative divided by positive value, it will now give you still negative, making the quotient of what? Of skewness to be negative. So it means that it tends towards the what? Towards the left. It's a left skewed distribution. A left skewed what? Distribution. You understand? And if you watch here now, you find out that our mean is less than the what? The median. And we gave ourselves a condition that in a left skewed distribution, that the mean is less than the what? The median. That's exactly what we are seeing here, which has been reflected by this quotient of variation. Sorry, quotient of skewness, where the data is skewed. So this data is skewed to the left-tailed distribution or left-tailed observations. Or you can equally say that you can calculate the quotient of variation k is given as 3 into mean minus what? Median all over STD. In that case, we are going to bring in the value of what? Mean here. So, and the value of our mean is this quantity. You minus the median. Median is still remains what? 1. You divide it by this. The same value you have here is the same value you have here. So it is still skewed to the left. But I want to point out here, when you are done calculating the quotient of skewness and the value happens to be negative, distribution is stayed to the what? To the left. If after calculating it, the value becomes positive, distribution is stayed to the what? To the right. But after calculating it and it happens to be what? To be 0, the implication there is that the mean and mode are the same thing. And if the mean and mode are the same thing, invariably, that thing is symmetrical. It lies at the what? At the center. So that's what you need to take from here. When skewness is negative, stay to the left, positive, stay to the right, 0, symmetrical observations. So thank you for following us as we went about providing solutions to this. Let us quickly now go about doing it now for an ungrouped frequency table. So we are going to look at measures of central tendency for an ungrouped frequency table. So permit me to clean here. So we talk about the measures of central tendency and dispersion. Measures of central tendency. Permit me to write this as central tendency and then dispersion. So what I mean by this is measures of central tendency and dispersion. That's what I mean. Then the idea is for ungrouped frequency table. Ungrouped frequency table. Ungrouped frequency table. And of course, we know that for our own group frequency table, we are going to have this thing occurring this way. We have this thing occurring this way. We have this occurring this way. Then let me call here my x, and I should call here my f. This is my x, this is my f. Let me say I have x1 here. And that x1 occurs something like a f1. Then I have something like what? X2. And that my x2 occurred what? F2. Up to what we have what? Xn. And it occurred what? Fn. What I'm trying to say here is that x1 occurred of the number of times of what? F1. And my x2 occurred the number of times of what? My f2. And my up to what? Xn, which occurred up to the number of what? Xn. This thing can be shown equivalently as something like this. Can show it as equivalently as something like this, where you have this, you have this, you have x here, you have f. Then you have something like what? You have something like 1 or 0. 0 occurred 2 times. You have something like 1. Let me use 1 so don't to confuse you with this. Occurred 2 times. 2 occurred something like 4 times. Up to what? 8 occurs something like 2 times. This is just something like this. That my 1 occurred 2 times, my 2 occurred 4 times, down to my 8 that occurred 2 times. So if I want to calculate mean using this idea, measure of central tendency now, I am going to say that my mean, x bar now, is going to be summation of fx all over summation of f. Summation of fx means I am going to say this time, this time, this. At the end, I will sum all of them. All over summing all these f1, f2. So summation of fx all over what? F. Of course, when we come here, then we now talk about what we call median. We are not going to waste time here. Median is the central observation when the data has been assorted in ascending order of their values. So we are going to see when we draw a real life example how to obtain it from what? From the table. Then we now talk about mode. Mode, of course, is the number with the highest occurrence. So we are going to come and look at their frequencies and know the frequency that is the highest. We now match it with that observation, and that observation becomes the mode because it has the highest frequency. So when we want to obtain the mode, our eyes should be at the frequency to obtain the what? The number of to see the frequency that is what? Highest. So these are what we call the measures of central tendency. Then we enter into what? Into dispersion. Now, of course, when we talk about dispersion, we are going to talk about what? Range. And when we talk about range, range is going to be the highest minus the what? The lowest. Traditionally, when they present data already in the table, either grouped or ungrouped, they have assorted the observation in ascending order. So most likely, just like what I have here, 8 here is the highest observation and 1 here is the lowest observation. So you quickly say 8 minus 1, which is 7. But if you are using this to present it, the range is going to be xn minus x1. That is, you are going to have xn minus what? X what? 1. Whatever observation that is here minus the observation that is here becomes your what? Your range. And then when you now talk about the variance, we are talking about the variance. So we now say that our variance is going to be that this is summation. We are going to write the formula for when it is not, the formula for the one we consider non-computational formula, and write the formula for the one we consider computational formula. You understand? So we are going to come here now, and then we give that this is now summation of f into x minus what? X bar all squared all over what? Summation of what? Of f. And this condition is going to be when summation of what? F is greater than or equal to what? 30. When summation of f is greater than or equal to what? 30. That's when we use this particular formula. But then we are going to use our variance equals summation of f into x minus x bar all squared all over summation of f minus 1 when summation of f is less than what? 30. So this is the variance we use when summation of f is what? Is greater than or equal to 30. This is the variance we use when summation of f is less than or equal to what? 30. So we are talking for the ungrouped frequency table. So I will quickly come and write each computational what formula. Permit me to call the call that's coming here. Sorry, a call came into my phone and they interrupted the recording of the class, and I'm so sorry about that. I'm deeply sorry for interrupting the class. So we just stopped at when we said let us write the computational formula, and I say that for the computational formula we are going to use for calculating variance when we have an ungrouped frequency table is that S is given as summation of fx squared minus summation of fx all raised to power 2 all over summation of f all over summation of what? F, when summation of f is greater than or equal to 30. But we are going to use this one that is all over summation of f minus 1 when summation of f is less than 30. So this is actually what we are going to do when we talk about what? The variance. Understand? So we are going to draw small example, and from that small example, be able to do a lot of illustrations on how to calculate all of these. So permit me to clean the board while we take an example. Okay. Make the board to be neater. Make the board to be neater. Okay. Make the board to be quite neater. Okay, let us say that the example we are going to take is going to occur this way. That I have observation, I have a table like this, and that table says that here is my what? My x, here is my f. Then I have something like minus 1. Then I have something like what? 2. I have something like 0. I have something like 1. Then I have something 1, and I have 1. I have something like 2, and I have maybe 3. Let me say I have something of this kind. This is what I have. Okay? So this is this plus this will be able to give me 3. To this, give me 4. To this will give me 7. Give me 7. So we are going to use this data I have here to provide answers to all these things I'm going to write. We are going to use it to provide answer to get the mean, use it to get the what? Median, use it to get the what? The mode, use it to get the what? The range, use it to get the what? The variance, use it to get the standard deviation, STD, use it to get the what? Coefficient of variation, use it to get K, coefficient of skewness. So with this, we can say we have learned something about this. Okay, so I'll quickly come over here so we don't waste time. If I have something of this kind, I'm going to arrange it this way so it will be easier for me to handle. So I'll now come here and write my x and write my what? My f. Then my x is minus 1, 0, 1, and 2. Then my frequency here is 2, 1, 1, and 3. So I'll have something like this. Have something like this. Then have something like this. Then I'll come here and write f of x. So that I'll be able to say this times this, I'll report it here. So minus 1 times 2 is minus what? 2. 0 times 1, 0. 1 times 1, 1. 2 times 3 is what? 6. I'll underline. I'll sum all the f and I'll sum all the x. And let me equally sum this my x because I'll be needing it when I want to calculate variance. If I sum this, Minus 1 plus 0 is minus 1, plus 1 is 0. So I have here to be what? To be 2. Which is the same thing like saying 2 plus 1, 3, minus 1 to give you this. Then I'll come to frequency. 2 plus 1 is 3, plus 1, 4, plus 3, 7. I'll come here. This is minus 2 plus 0 is minus 2. Plus 1, minus 1. Plus 6, minus 5. Which is the same thing like say, 5. Which is the same thing like saying 6 plus 1 is 7. Minus 2 is 5. So here becomes my what? My 5. Here is my 5. Then permit me to clean here. So I'll clean this place. So we are talking about our mean. Our mean is going to be x bar equals summation of fx. Fx all over summation of f. Summation of fx is this, which I have here. Because this is summation. So I will put summation here. This summation I put here is talking about summation of x, 2. Summation of f, 7. Summation of fx is 5. So I have that this equals, summation of fx is what? Is 5. Summation of f is what? Is 7. So my mean is 5 over 7. Then we now talk about median. Median. Now if you watch now, this our data set has now assorted in ascending order. Minus 1 is least, followed by 0, 1, and this. Then we begin to ask ourselves a question. We are going to use what we call the median locator. Median locator is that we have something like this, that locator of median, we call it median locator. Median locator is giving us summation of f all over what? N. If n equals even. And then summation of f over 2 if n is even, or summation of f all over what? Summation of f minus 1 all over what? 2. For n, summation of f plus 1 over 2 for n equals what? Odd. Please, what we mean for n here is just like, let me be using even for summation of f, and then in place of this, for summation of f. That is to say, when your summation of f is even number, divide it by 2 and use it to locate the median. But when your summation of f is odd, add 1 to it, divide it by 2 and use it to locate the median. My own summation of f here is what? Is 7. So 7 is an odd number. Because 7 is an odd number, I am going to add 1 to it. It becomes 7 plus 1 will give me 8. 8 divided by 2 will give me what? 4. I'll use this 4 to locate the what? The median. I will now come here. I can either start from here or I can start from here. If I start from here, I will ask myself, is 4 found in 2? No. 2 plus 1 is what? 3. Is 4 found in 3? No. 3 plus 1 is what? 4. Is 4 found in 4? Yes. So I am here. What is that value that is on top here? 1. So my median here is what? Is 1. Or I can come here. Is 4 found in 3? No. 3 plus 1 is what? 4. Is 4 found in this 4? Yes. What is it that have it here is what? Is 1. So which means my median is equals to 1. My median equals what? 1. Then we talk about mode. Mode is the number with the highest frequency. Let us come and check our frequency. Look at the frequency. The highest frequency is what? Is 3. What number has that 3? 2. So my mode is what? Is 2. So I've gotten my mean. Our mean is 5 over 7. Our median is 1. Our mode is 2. And you saw all what we did there. So we go and get our what? Our range. Our range. So when you talk about what? Range, you are talking about the highest minus the lowest. Highest minus the lowest. The highest observation here is what? 2. The lowest observation here is what? Minus 1. So my range R equals what? Highest is what? 2 minus. Lowest is minus 1, minus 1. Minus minus is plus. It becomes 2 plus 1, which will give me what? 3. So my range is what? Is 3. We now move to the what? To the variance. So please, permit me to clean here. But let us bear in mind that our median equals what? 1. Our mode equals what? 2. Our mean x bar equals what? 5/7. Let us bear those things in mind while I clean here. Yeah, for me to get the variance, what I am going to do is to use the computational formula so it will be easier for me. And the computational formula says that my variance s squared is given as summation of f of x raised to power 2 minus summation of f of x all raised to power 2 all over summation of what? F all over summation of f minus 1. Because my summation of what? F is less than what? 30. That's why I'm using this one. It's less than 30. So I'll now look here. I have not squared my x in this table. So I'll quickly come and square x in this table. So what I'll do is to extend this table, do like this, and put what? X squared. I will square the x. So minus 1 squared, 1, 0 squared, 0, 1 squared, 1, 2 squared, 4. But what I have here is fx squared. So I have to multiply this x squared by f. So I will extend this my table and do something like this, and I'll have what? F x squared. So I'll be using this x, this value of f, to multiply this x squared. So it becomes 2 times 1 is what? 2. 1 times 0, 0. 1 times 1, 1. And then 3 times 4 will give me what? 12. So I will now do all over for me to sum this thing. 1 plus 0, 0 plus 1, 2 plus this, 6. So I have here to do what? 6. Then I'll come here, I'll sum all these things. 2 plus 0 is what? 2 plus 1, 3 plus 12 is 15. So I have here to be what? 15. So by implication, I will come to this formula. Anywhere I see summation of fx squared, I will use 15. Anywhere I see summation of fx, I will use 5. So in that case, this equals, in place of this, I'll write 15 minus. In place of summation of fx, I'll use what? 5. So here is what? 5. Then I will do this. Because it is squared, I will square it, which is just like all over. Then in place of summation of f is what? 7. I'll use 7 here, all over. Then in place of a summation of f minus 1, I am going to say that is 7 minus 1, which is going to give me 6. And of course, you and I know, or you know, that this is what? 15 minus 25 all over what? 7 all over 6. So this, whatever thing you get here, stands for our variance. And then my standard deviation S alone is square root of what you have here, 15 minus 25 all over 7 all over 6. That is the standard deviation. Then we quickly discuss what we call we have talked about the variance, talked about the standard deviation. So we now quickly talk about what we call the coefficient of variation. Coefficient of what? Variation. Of course, our coefficient of variation is given as that this is what? C dot what? V is given as, we have 100 times S all over X bar. And of course, your 100 is, you know it, your SS is standard deviation, which is the value you are going to get here. So it goes in here. And then for your X bar, the value of X bar is 5/7. It goes in here. So it is, that one is quickly taken care of. Then we now talk about what we call the coefficient of skewness. In the coefficient of skewness, we gave ourselves a formula. Permit me to clean here quickly. You know why we use this formula, and less than 30. We use this thing. You know how we obtain from this table all this value, and then we substitute it. So we now quickly come here, and then we now say this place that our Coefficient of skewness K is given as we have a mean minus mode all over STD. Our mean is 5/7. So it becomes 5/7 in place of mean minus. Our mode is 2 all over. Whatever the value of standard deviation we got enters this place. And whatever thing you get becomes what we call coefficient of variations. Thank you very, very much. I really want to believe that we actually carried you along very well in this particular class. So permit me to clean the board. Permit me to clean the board. Okay. At times there are questions that they raise to people to answer as concerns measures of central tendency. Measures of central tendency. So many questions that they raise and ask people to provide the answers to them. So in order not to make this class too large, we are going to have a next class. And in our next class, we are going to tag it problem solving in the measures of central tendency. Problem solving in the measures of central tendency for both an array of data and ungrouped frequency table. So at the moment we finish it now, we'll be able to enter into measures of central tendency and dispersion for grouped frequency table. So thank you very much and stay firm and calm waiting for us when we are going to unveil so many challenging questions available both in JAM, in WAEC, in JUPEB, in screening about measures of central tendency and dispersion. God bless you.